Hello friends, welcome to another video of circuit analysis. I am Dr. Sujay Shah, Associate Professor in Department of Basic Sciences, SR University. So today we are going to learn about the mesh analysis problem. The mesh analysis. So the mesh analysis problem solving. So we have like a source transformation 1-2 video, then nodal analysis 1-2 video, then mesh analysis video number 1, and this will be our last video in this techniques of the circuit analysis. So we'll go to any other video after that. So you can find out those in our next videos. So today we are going to learn about mesh analysis 2, which is actually the problem solving. So without doing any other kind of introduction, we'll start. Before you, if you are new to my channel, then please subscribe to my channel and also comment on that what kind of video you need actually, and you can tell me that any other topic also you can choose, and we will make some intuitive videos and problem solving. So let us start. So you can have, like, we already have this mesh analysis problem solving theory, but to check that we just come to we come at this part. So check that if the network is planar or not. Like planar means that it can be fitted in a two-dimensional paper or not. Sometimes in the previous video we have not mentioned about there might be circuit which is 3D. And then it is very difficult to apply mesh analysis because the current we are considering, it is also always two-dimensional. So check that whether the circuit is planar or not. Then if not, then we have to make it planar. So by time being, the example what we are doing, it is always 2D. So we don't have to worry about the 3D and 2D differences. But yes, we have to consider if it is not 2D, then we have to make it 2D. Now we have to identify the mesh and label the mesh currents either in clockwise or anti-clockwise. So if you are considering clockwise direction, then you have to take all the current in clockwise direction. If you are taking anti-clockwise direction, then you have to take all the current in anti-clockwise direction. So you cannot change the direction, right? It gives a lot of confusion, but ultimately the answer will be the same. But still we have to be consistent, and always we will take clockwise direction current. Okay, observe the amount of current that flows through each element in terms of, so we observe the amount of current flows through each element in terms of mesh current. So, and each mesh, so we'll give the actual numbers, and then you can get an idea that what we are talking about. Then write the mesh equations that we have shown in our previous video by applying KVL first and then apply Ohm's law, then solve the mesh equation in step 3 and obtained in step 3 in here. So, and then we will can go and get the mesh currents, and then we can calculate the other mesh parameters. So this is pretty easy, pretty straightforward. So we can get, so without doing much of some kind of introduction, we'll go to the next slide. Okay. Yeah. So this is a kind of mesh we are looking at, and then we have to find out the voltage across all the resistors and power delivered and consumed by each element using mesh analysis. Okay, so this is something we have to work on. Okay, so let us start what we have to do. So first of all, let us say that the step 1, there are two mesh. This is, we can say that this is A, B, C, D and EF. So these are two mesh, and I can consider that the mesh currents as, we considering that I1 and I2 current we are considering. You can write down this kind of notation in this kind of problem solving. Okay. Now this mesh current, the I current flows through 220 volt source, then 5 ohm resistance, then 10 ohm resistance, then comes back, and I2 current flows through 30 ohm resistance, then 80 volt source, then 10 ohm resistance. So these are, So this is both mesh, and 10 ohm resistance, this 10 ohm resistance is a common resistance for both the loop. Okay. So to find the voltage of this circuit, so first of all, what we have meant that this current we have chosen as I1, and the current here we chosen as I2 in both in clockwise direction. Then this is A, we have named this as A, B, C, D, and this is EF that you can give. So now it is pretty simple in that sense that you can put the KVL. Now here this is written in different fashion, but you can always do always think in different fashion. So whatever it is there that is already there in your hand, but for sake of my convention, or like for a different convention, you can utilize this KVL in different way, so that you can get another flavor of it. So let's say, so without doing any other, so let us say in that way. So this current, this ABCD loop has current which is coming out of this positive terminal. You can see that is going from A, B, C, D, and it is coming to A again. So it is coming out of the positive terminal. So what I told, that the KVL law states that the sum of the source voltages is equal to the sum of the voltage drop. So now as the current is coming out of the 20 volt resistance, so you can write down 20 is equal to, then the drops, the drop at 5 ohm resistance is 5 times I1, then plus, then it has 10 ohm resistance, so 10 multiplied by, now we are considering A, B, C, D loop, so it should be I1 minus I2, as the influence of I2 current is also there on this 10 ohm resistance. So let us make a bit do this some kind of simplification, and then it becomes 15 I1 minus 10 I2 equal to 20. Correct? So this is something we had. So this is equation number 1. Okay, so here also the same equation they have got. Ultimately you are going to get the same equation, but in maybe it is in some kind of different fashion. Okay, now from equation from this loop B, E, F, C, we can have that the same thing. Now the current is coming out of this loop again, so this is reverse. Remember, there is minus plus, so the current is coming out of the positive terminal, so it should be like 80, it is positive, and will be equal to, the drops are at 30 and 10, so 30 times I2 plus 10 ohm resistance and I2 minus I1. Okay, now this I1 will be like 10 I1 plus 40 I2, and this is 80. Okay, so this is something you can have. This is equation number 2. Now these two simultaneous equations are obviously solvable, and if you don't believe me, then we can do a solution pretty quick. How to do that? So we can multiply this by 2, and we can multiply this by 3, and then we add. So it is 30 I1 minus 20 I2 equal to 40, and then here it is minus 30 I1 plus 120 I2 equal to 240. Now we add, so these two cancels out, it gives rise to 100 I2 equal to 280, which gives I2 equal to 2.8 ampere, which is here. Now as we got I2, we can also get I1. I1 we can write it as 20 plus 10 I2 divided by 15, which is given by 20 plus 28 as I2 is 2.8, so 10 I2 is 28 by 15, so which is 48 over 15 ampere. So you can calculate, so we can go to our calculator, and this is 48 divided by 15, which is 3.2. okay, so this is actually equal to, which is given by 3.2 ampere, which is also there. So you can understand that solving by mesh analysis is not a very big deal. This particular problem can also be solved by nodal analysis, but you can see that the nodes are obviously A and B and F. So these are the three nodes, and you can calculate the nodal voltages accordingly, and we can also calculate the current. So now we can calculate the other parameters here. But let us say that if you want to solve this problem by source transformation, then probably we may not be in very good shape, because here the voltage across all the resistors you might need, and then probably if you still do, it's not a worthy of. So you can do that, but it won't be that much of like a relief for you. So I better think that, okay, no, never don't arbitrarily choose any technique. If you just simply given that find the voltage across all resistors, power delivered and power consumed by each element using mesh analysis, that I think this is the way it should do. If nothing mentioned, still you can use mesh analysis. Okay, now we have our two current I1, which is here I1, which is given by 3.2 ampere, and I2, which is here, it is I2, which is given by 2.8 ampere. Now current through 20 volt is also 3.2, current through 5 ohm is 3.2, current through 10 ohm resistance. Now see, the I1 is flowing from down to top, and I1 is going from I2 this is I2, this is I1. Okay, so the influence of I1 is bigger. So the current through resistance is actually 3.2 minus 2.8 equal to 0.4. It is downward. It is coming downward. Okay. Now current through 30 ohm resistance is 2.8, and current through 80 volt source, it is 2.8. So this is all we know. Now voltage drops. Now voltage drop is simply current multiplied by resistance. So for 5 ohm resistance is 3.2 times 5, 16. Current across 10 ohm resistance is 0.4 times it is 4. Current through this 30 ohm resistance, here it is 2.8 times 48 equal to 84 volt. Now this is the current, this is the power, this is the voltage which are actually dissipated. Okay, so the power supplied and consumed. So the power supplied by 20 volt source is volt times current, right? So the current through the 20 volt resistance, 20 volt source is 3.2 ampere, and here it is 2.8 ampere. So the power is actually through this is 64 watt, and power through this 80 volt source, is 224 volt. Now it is said as minus 80 volt source, which is I think it is not a very correct way to write it down, because it is always like power is always positive. It's not a negative kind of thing. So it is moving here, so we still can say this is like a positive, right? So this is 224 and 64. Now the power consumed at 16 ohm resistance, there is no 16 ohm actually, this is 5, so this is 5, 10 and 30. So for so the voltage across 5 ohm resistance is 16 volts, so 16 volt times 3.2 is given by, it should be like this, it is not 51.6, it is actually, it is not 51.6. We can calculate this. We can calculate as we can calculate as 2 51.2. 16 to the 32, then 3, then 60 is 48 and 51. Okay. Now power consumed through 10 ohm resistance is the voltage drop across is 4, the current is 0.4, this is 1.6. And then current power consumed by 30 ohm resistance. So the 30 ohm resistance has a voltage drop as around is 84 volt. And then it has 2.8 is running through it. So then the power will be equal to 8 4s are 64 and this 224 ohm, 224 watt. Okay, so this is the power consumed, or like power consumed by all the like power supplied and consumed by all the elements. So the consumed is by resistances and the power supplied by these two. So power supplied by this 20 volt source is 64 watt, and this is for this 80 volt source. It is 224 watt. So the total power, so this is power supplied, and power consumed by 5 ohm resistance is the voltage drop across the 5 ohm resistance times voltage drops across the 5 ohm resistance times the current. So it is actually 3.2 times 1.16 equal to 51.2. Then by 10 ohm resistance is 0.4 times 4, and for 30 ohm resistance is 2.8 times 84. So the total power consumed, power supplied is 64 plus 224 watt equal to 288 watt, and total power consumed as 5 ohm, power consumed at 10 ohm, and power consumed at 30 ohm is. So this gives 2 plus 8 plus 10, which is 1, then 1 plus 5, 6 plus 1, 7 plus 1, 8, then 3 plus 5, 8, and then 2. So 288 supplied and 288 consumed, which is ideally the case that whatever you are supplying power, that is consumed by the elements which can consume. So this is basically nothing new. This is another manifestation of the conservation of energy. So this is something which is not new. So we are also verifying. We have also verified the law of conservation of energy by this mesh analysis problem. Okay. So let us go to our next problem. So this is something different. So here it is written. It is something which is, it is not just not two voltage sources. There are one voltage source and another is current source. The voltage source is 90 volt battery, and the current source is 50 ampere. Now many people will say that no sir, we will transform this into voltage source and then we can do. So this is actually not true. We cannot, that is not allowed. So instead of what you can do, you can still try to figure out that what is what. So it is simple. It is no rocket science in it. We can still manipulate. We can still calculate the find the current through all the elements, that we can still calculate. Okay. So let us start. So the same thing we will do. We consider I1 current in left loop and I2 current in the right loop. I am not considering the ABCD nomenclature because that will give you some confusion, but still we can write down this is 5 ampere, this is 90 volts, and then we can put the equation here. So on the left hand side we can write down say that, so the voltage source, you can say that the current is actually coming out of the positive terminal, so the 90 volt resistance, 90 volt ohm is actually like 90 volts, so it is equal to, which is positive, then 90 times I1 plus 6 into I1 minus I2, which gives you 15 I1 minus 6 I2, which is 90. Equation number 1. Understood? Now the thing is, this equation, this particular loop has a current source. Now look at this. We have considered the current. To flow in this direction, right? But already there is a current which is flowing through this 5 ampere source. So what we can do? So as there is no other source is available, okay, there is no other. So we can simply write down. We can simply sort that out. That this is something. It is we can directly tell you that this second loop as it has a current source of 5 ampere and this I2 is considered as clockwise, but this loop has a current source here, and here you can see that the current we are considering is going in this direction, but current of this current source going from down to top, so that immediately you can say that the I2 is opposite of the current source. So just give me a 30 second, that we have considered this current in this loop as I2, but the current, this loop already has a current source in going in the down to top fashion. So hence this I2 must be equal to the current in a opposite direction. So now you can put the value here. So we can say that 90 will be equal to 15 I1 plus 30. Then immediately you can say I1 will be 60 by 15, right? This is goes that side, so it is 4 ampere. That's it. So we have a current, so I1 equal to 4 ampere and I2 equal to minus 5 ampere. Without solving the second equation, we can, second loop equation, second mesh equation, we can actually write down the current equation here. Okay. Now which is actually manifested in our solution, and you can do in any other way what you like. So this is I1, this is I2, and the current is equal to, like, this is 4 ampere and this is minus 5 ampere. Now the current through each element we need to find out. So current through R1 is 4 ampere, current through 8 ohm is minus 5 ampere, but current through this, how to write down? So I1 is from top to bottom and I2 is from down to top, and you can say that you can tell me that 4 ampere current, the 4 ampere current is going from, this 4 ampere current is going from top to bottom through I6, and I2 we have considered, I1 is coming from top to bottom, which is positive, so our convention is right, but I2 should have been going towards like bottom to top, but it is minus 5 ampere, so definitely the current is not going from bottom to top, it is actually coming from, so the I2 has minus 5 ampere, that means it is actually not in the clockwise direction but in the counterclockwise direction. So at 6 ohm, so the current through 6 ohm is actually 4 plus 5 equal to 9 ampere, and current through 9 ohm is 4 ampere, and current through 8 ohm is equal to minus 5 ampere. Okay, so this is our this is the solution, and then you can calculate the other things, that okay, what are the voltage across the, so this is again the, so this part is 50 90 volt, this is 5 ampere, and so this current is here is 9 ampere, here it is going in positive directions 4 ampere, this is also going in 5 ampere. So that we have already calculated. Now you can calculate the voltages. So that is something that simply V equal to IR. So it will be 36 across 9 ohm, 40 across 8 ohm, and 54 across this 6 ohm resistance. So this is something pretty straightforward, and hopefully you have enjoyed the lecture, and this will be our last lecture in mesh analysis techniques. Hopefully we can come out with a much more much more fundamental aspects of circuit analysis, maybe because many of you are requesting me to give me some fundamental basics of circuit analysis, maybe KVL or KCL, that we can work on, and maybe in some video we can still make those concepts clear. Okay, now if you remember, before we conclude our video, if you remember correctly, for any I think for our mesh analysis problem solving theory, or in the previous video actually we have done the nodal analysis problem solving. If you remember that nodal analysis problem solving video number 2, there we have asked you about the to solve this problem by nodal analysis. Hopefully you have done this. If not, then please try, because that will be only way you can actually find out what is the delicacies of these problems. So here also you can have the problem as a nodal analysis problem here, and this particular problem can be easily solved, maybe within like minutes you can solve by mesh analysis. If you can understand this, just simply take clockwise current on these two loops, then write down the KVL equation, and then you can simply solve the two simultaneous equation by I1 and I2, and that will be all. So if you can put the nodal analysis problem and this mesh analysis problem side by side, that will be much more much more important for your understanding about the techniques, that some problem can be solved by easier method, some problem cannot be solved by the same method, and some problem can be solved in quick time by a particular method. So this is that's why we are taking a different kind of technique. So this will be our last video about the techniques of solving circuit analysis problems, but there are many, we have not touched upon the T-pi transformation, the star delta transformation, or we have not taken into consideration of Thevenin's theorem, Norton's theorem, superposition theorem, and then theorem of maximum power transfer. So these are many concepts we have not touched upon. Maybe later on we can actually have those problems, and same problem can be solved by Thevenin's theorem or Norton's theorem, or any other problem can be solved by different ways by simply using those kind of technique. Mostly, frankly speaking, Thevenin's theorem and Norton's theorem are deals with only by if there is a particular resistance or load resistance and you don't know what is inside, so then simply you can simply by applying Thevenin's theorem you can transform the entire circuit into one particular voltage source and only one resistance by applying Thevenin's theorem. So it is much more advanced than source transformation problem. Similarly, Norton's theorem, same circuit can be transformed into one current source and a parallel resistance. Similarly, by the virtue of maximum power transfer theorem, we can show up that what is the resistance to be attached with the circuit, the load resistance, what will be the load resistance, so that the maximum power can be drawn or maximum power can be dissipated from out of the circuit. So that also is a nice intuitive theorem. And also T-pi and star delta transformation are to get equivalent resistance of a very complicated circuit, and which can be maybe in our next subsequent classes we can do those problems. Up to now, this is where we end our circuit analysis lectures, and hopefully we can come back. Okay. So thank you very much for your time, and hopefully we'll come again with a new and better video. So keep smiling. Have a good day. Bye bye.